Let's talk about the basics of graphing quadratic equations. Now there's a few different ways that these equations can show up, but let's start with this ax squared plus bx plus c. What a tells us is just whether or not the equation is opening upward or downward. So parabola is the description of the shape, and it will either look like this, opening upward, or like this, opening downward. And it'll come down to whether a is positive or negative. So let's go ahead and talk about that with this example down here where we have x squared minus 6x plus 8. So, and we just want to know, does the parabola open upward or downward? So with this, we have a equals just a positive 1. So because that is a positive value, that tells me that it opens upward. So with that, I get an idea of the general shape of the parabola will look something like this. The vertex is the turning point of the graph and occurs at either the maximum or minimum point. So if we have a graph that opens upward, the minimum point is our vertex and comes through as an xy coordinate. If our parabola opens downward, it comes through as a maximum, again, an xy coordinate. So for our example down below, we're being given the vertex is 3, negative 1. So with that, we could go ahead and graph that coordinate on my grid down here with 3, negative 1 being the turning point of my graph. And then from there, all I have is this general idea that it's probably doing something like this, but we'll get some more exact coordinates in a bit. The axis of symmetry is the vertical line that passes through the vertex. So with each of these, there's a line of symmetry that goes through our vertex so that if we folded our paper in half, that parabola would land on top of itself. And what we're going to use is a vertical line, so that's x equals a number, and that number comes from the x coordinate of our vertex. So in part B down there, we have our vertex of 3, negative 1. So what is the axis of symmetry? We'll go x equals, and then that positive 3 for that x coordinate. So graphically what that's doing is we don't have anything to plot, but we can visualize this axis of symmetry as this vertical line going through x equals 3. Okay, next up, the y-intercept occurs where the graph crosses the y-axis. So this is where x is equal to 0, so it's a coordinate where we have 0, and then our output. And what should happen is if we have this ax squared plus bx plus c form, the output should be that value for c. So let's see that come through in part C down here. So this is where we're plugging in x equals 0. So we have y equals 0 squared minus 6 times 0 plus 8, which is going to leave us with y equals 8. So we have the coordinate 0, 8 as our y-intercept. Now that gives us one coordinate. However, it's kind of giving us a second coordinate too with our axis of symmetry. So I'm 3 units from the axis of symmetry. So on the other side, I would have this reflection of that same coordinate just based on how the symmetry of parabolas work. The x-intercepts occur where the graph crosses or touches the x-axis. So this is where y equals 0. And there's a few different cases here. We could have 2 x-intercepts, we could have 1, we could have none. So the case where there's 2 x-intercepts, that comes through when we cross the x-axis twice. 1 x-intercept is where the vertex is on the x-axis, so we're just touching once. And then we could have the case where we don't have any, where the parabola is kind of floating above and never crosses the x-axis. So those are our scenarios there. So this comes from solving y equals 0. So what we would do is go 0 equals x squared minus 6x plus 8. And now this becomes a quadratic equation to solve. So we're going to use our methods that we learned in the previous videos with either factoring or square root method, completing the square, or quadratic formula. What I'm going to do with this one is I'm going to go ahead and try to factor it. So two values that add up to or multiply to positive 8 add up to negative 6 is going to be a negative 4 and a negative 2. So x minus 4 equals 0, which would be x equals 4, or x minus 2 equals 0, which would be x equals positive 2. And from there, I get 2 more coordinates. So at positive 4 and positive 2, and that gives me a pretty good guide for putting the graph together. So let's go ahead and connect these dots with the nice curved parabola. Make sure to not draw straight lines with these. This has curvature to it. So we want to curve those lines as we graph. Okay, so lots of information that we get from that ax squared plus bx plus c form. Does it open upward or downward? Axis of symmetry if we have our vertex, and then y-intercept and x-intercepts, which there should always be one y-intercept, but x-intercept is flexible of it could be 2, 1, or none. Let's go ahead onto this next piece of talking about the vertex and how we find the vertex. So if we have this format, ax squared plus bx plus c, what we can do is use x equals negative b over 2a to solve for the x coordinate. So with these equations down here, we're going to work with a is 1, b is negative 6, c is 8, just like we did with our quadratic formula. But now because I'm interested in the vertex, I'm just going x equals negative b over 2 times a, which b is a negative 6, and a is a positive 1. So it'll give me positive 6 over 2, so we have 3. So for our vertex, I'm going to start down here. We have 3. We don't have the y-coordinate yet. And to find the y-coordinate, what we'll do is we'll take that value we just solved for x and plug it into our equation. So we have 3 squared minus 6 times 3 plus 8. So a 9 minus 18 plus 8. So a negative 9 plus 8, which is a negative 1. So that y-coordinate is negative 1. So you can solve for the vertex given our equation. Let's try that with another case here. We have a is negative 2, b is negative 6, and c is 9. Don't really need c with these, but it's good practice to just have those. So we'll have negative b over 2 times a. B is negative 6. A is a negative 2. So we will have a positive 6 over 4. So we have 3 halves. So for my coordinate that I'm getting, we have our x-coordinate of 3 halves, and I need my y-coordinate. So we're going to go y equals negative 2 times 3 halves squared minus 6 times 3 halves plus 9. And let's go ahead and... Ooh, I lost a negative in the process. Sorry. That should be a negative 4 down there, so that makes it a negative 3 halves. Oh, that's important. Negative 3 halves. Negative. Negative. Okay, good. Caught that early enough. Okay, y equals negative 2 times, and that'll be a positive 9/4. And then we'll have plus 18 divided by 2, which is 9, plus 9. So y equals a negative 18/4, which is a negative 9 halves, plus 18, which I'll go ahead and write that as 36 halves so I have my common denominator. So y is going to be equal to 27 halves. And with that, we have our y-coordinate. A little messy one. It's good to go through those. Okay, so let's look at another quadratic equation here and go through our pieces, this time finding our vertex. So opening upward or downward, I'm looking at, we have an a equals negative 1, b equals positive 8, and c equals negative 7. So a is negative 1, so because that is negative, that means our parabola is going to open downward. So something with this shape. Finding the vertex, we're going to go x equals negative b over 2a. So b is a positive 8, a is a negative 1. So we're going to have negative 8 over negative 2 for a positive 4. And that means y is going to be equal to negative 4 squared plus 8 times 4 minus 7. So negative 16 plus 32 minus 7, which is 16 minus 7 is 9. So we have the coordinate for 9. If we needed the axis of symmetry, it would be at x equals 4. Okay, let's go units of 1. We have our x-axis and our y-axis. And we're going to go 4, 3, 6, 9. And there's our vertex. And then what I could kind of do is visualize that axis of symmetry just to help out as I start plotting some points. Okay, the y-intercept, so that's where we're plugging in 0. So we'll have y equals negative 0 squared plus 8 times 0 minus 7, which will just leave us with the minus 7. So we have the coordinate 0, negative 7, which is down here. So 3, 6, 7. And we could use symmetry to get a second coordinate, which is over there. This is a pretty good start. We can get some more information with our x-intercepts, which would be to solve 0 equals negative x squared plus 8x minus 7. I'm going to go ahead and divide everything by a negative 1 so that I have something that I can factor. So x squared minus 8x plus 7. So that'll be an x minus 1 times x minus 7. So x minus 1 equals 0 would solve to be x equals positive 1. So there's one coordinate. X minus 7 equals 0 would give me x equals positive 7 for the coordinate 7, 0. So I'd have 1, 0 and 7, 0. Like that. That's a pretty good amount of information to get a decent shape of the parabola there. Okay, so there's our properties for how to find the vertex as well as other features of our quadratic equations.